Good morning, afternoon, evening, or night, depending on when you're watching this. My name is Rhiannon. I'm going to do a presentation on black holes. I've always been fascinated by black holes and the whole process behind how they are born, as well as how they consume pretty much anything in their path. Some people may ask, what is a black hole? Well, NASA quotes a black hole as a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. While that is all good and makes sense, how do they even come into existence? For starters, there is the supernova option, like we learned in class, where the star has used up all of its energy and after a final pulse, collapses in itself, creating a black hole. Let's take a moment to review the parts of a black hole. There's the singularity, which is at the center of the black hole. Outside and surrounding the singularity is the event horizon. The event horizon is where no matter can escape the claws of gravity, and therefore sucked into the singularity. Just outside the event horizon is mostly gas, some dust, and other debris that have formed together because of the gravitational pull from the hole. Then there are the jets, and are believed to be the byproduct of the accretion disk. The jets that are tied with black holes are most active and fastest in space. This is due to the speed the jets need to have to be able to meet the escape velocity from the central point. There are a couple of methods that can be used to locate black holes in our universe. One example of that is with X-rays. Now you may be thinking you just said nothing can escape the singularity. How are we getting X-rays? Well, that has to do with the matter on the event horizon. The fact that it is spiraling to its ultimate demise creates energy and heat that we here on Earth are able to pick up through X-rays. There are a couple important people that have studied black holes and have some amazing findings about them. Let's take a look at Albert Einstein. In his theory of general relativity, new science summarizes it as being explained that what we perceive as the force of gravity is in fact the curvature of space and time. An example in layman's terms, if you place a child on a mattress, the mattress will dip and sag under the child's weight. When you roll an apple onto the bed, it will fall towards the child because the curvature in the mattress created by the gravity the child applies to it. Big scale idea. The gravity that our sun imposes in space is not actually causing the planets to be pulled by the sun to rotate around it, but the actual curved space-time dimension. Now, why aren't we being pulled into the sun like the apple was to the child? Well, we are moving a lot faster around the sun than the apple would a child. There was a recent discovery that actually proved the theory correct with the collision of two black holes being detected, but I'll get into that in the main presentation. There's also Stephen Hawking, who put into motion the theory of cosmology, explains it as a union of quantum mechanics and general theory of relativity. With Hawking radiation, the concept behind the idea is that particles that are around a black hole are constantly moving and bouncing off one another. In most cases, it's a positive and negative energy. While bouncing off one another, let's say they are moving closer and closer to the horizon. When all of a sudden they bounce and one goes into the horizon and the other does not. Now you have a particle that has technically escaped out into space because its partner in crime couldn't make it out of trouble. So in a sense, something can escape through the black hole.